So this is Introduction to Statistics, and this session is regarding normal distribution. Now we touched up on normal distribution before when we were talking about the z-score, right? So remember the empirical rule, remember the Chernobyl theorem. Those are basically a very rough sketch on what a normal distribution would look like. This is a graph of a normal distribution. And remember, normal distribution applies when you have a whole lot of data, a large data set. In our case, we'll just say normal data set, right? Normal data, normal distribution applies under any if an experiment, if a statistical experiment, if how about just a distribution meet one of the following three criterions. And I cannot spell. So, let me see. So the first criterion, so if you meet any one of those, then you're good to go. The first criterion is if sample size is larger than or equal to 30. Right? So in other words, the n, right, is bigger than or equal to 30. So that means if you're doing a survey, let's say you want to look for people's income, if you got 30 people or more, we just assume it's normal. Now, this is not actually true in real life. It all depends on what kind of situation you're in. But in our class, we just assume 30 is large enough. Now, in the time with Amazon and Google and Facebook, these guys, that's all they do is data. If you talk about 30 million, right, they have data points that can go off the roof. So it may or may not apply to us anymore, but it just makes it a little bit easier for us. B. Second criterion is if we assume, if the problem, right, the problem that was presented to you assumes normalcy or normality. What does that mean? If they just say the distribution is normal, right? So sometimes they will say, i.e., the assuming the population is normally distributed. So they say that, then you just say that's normal. C, the problem assume the distribution is bell curve shaped. And all that means is normal distribution, just like this guy right here, right? So if you see any one of those three, then you can already apply normal distribution. So now, what is so special about this thing? The middle guy, if you recall, is always the average. So in our case, right, that 75 right here will be right in the middle. Let me see if I can add a text box in here, right here. So just a very small text box. So basically, this guy right in the middle is considered. Let's see. Just make sure I make some space, and I can actually make this in front of the text. Okay, there you go. So make it into 75. Right. Like this. So right in the middle is 75. Right. Let me get the center. There you go. So like that. Right. So right in the middle is where that 75 points at. Think about, right? Normal distribution also means most people gravitate towards that average. And that's usually true normally, right? Think about your income, right? Think about your age. Most people's income tends to go towards, say 30, 40, 50,000, right? You're not going to see a whole bunch of people at a million, and you're not going to see a whole bunch of people unemployed, except for, during the pandemic and all that. But that is on a normal time, most people gravitate towards the middle. Same thing with age and height and weight, right? Now, when you go towards the right, it gets bigger. When it goes towards the left, it gets smaller. So, but how far, what is the scale, right? How far do we go? Well, here, look at this standard deviation. It's 3.6. That means 3.6 is how far normally the first step would take, like around here. So there will be like 78 something 0.6, and then the second step, third step. So the problem is for oh, I'm tripping. Should be 65. My bad. Sorry. So the mean is 65. Look at this thing. So for 75, is the x. Where should it go? That's the question. Well, 75 is obviously bigger than 65, so it's going to be on the right-hand side. The problem is, how far should we go? Right? 75 is 10 above 65. 10. Well, 10 is almost 3 times the standard deviation. There's a huge jump. So if it's like 1, let's say it's like 67 or something, it'd be right next to it, right? But when it's like 70, 75, you're going 10 above this thing. So that's 3 standard deviations worth almost. So that will be almost here. So you can, so basically the idea is the data points, the x-ray, 75, will be somewhere around this area. Just so it's like a visual guide, just kind of visually, where do they fit, where do the data fit, right? If you got something like 20, they'll be like around here, right? Or 40. But if you got something like 60, well, they'll be around here, right? They'll be a little bit closer. So now, calculate the standard score given the x value and those information. Now, let me give you the formula first. The formula for standard score, right, we call it Z. Z. Right, let me just insert this equation. It's going to be a fraction. Z equals x minus the mean. And where's the mean? Right here. Divided by the standard deviation, which is right here. Right. This is the equation. Now, just to make it a little bit easier for you guys, is, well, here is x. Let me see. It's always x minus the mean. There you go. So in general, this is always true. The z, the standard score, or we call it the z-score, some people call it the z-score, is the x that you're given, subtract the mean, divided by the standard deviation. So in our case, it's equal to, what is the x? Is 72.1, and the standard deviation is 72.1, which is a little bit strange. So subtract 75.4, like that. Right. So that's equal to, and just use a calculator, right? Be careful when you do fractions. Always do primacy for the numerator and the denominator if you have something that's more complicated. So 72.1, subtract 75.4, close primacy, divided by, now since the bottom is just one number, I'll just go ahead and do this. So that answer is going to be negative 0.04, well, we round to 2 decimals, so 0.05. So the answer would be negative 0.05. Well, what does it mean, though? This means, all right, let me put that at the bottom. This means the x, right, the data point x, is about 0.05 times of standard deviation less than the mean. So let's say if I have, say, 2. If the z-score is 2, that means I am 2 times the standard deviation above the mean. Now let's look at the other problem here. Say, calculate the standard score of the given listing. So it's the same thing, right? So let's see. So this one is, I don't know, this keeps changing the numbers here. So this would be insert. So it'll be 89.5, and again, let me do the fraction, 89.1 minus 88.2. So that's just using the formula. Equals, and again, I'll put this in the calculator, and there'll be 89.5 subtract 88.2. So this time I did not use the parameter. I just go ahead and hit enter, right? And then I will divide. So you can do that, divided by 89.1. And I have 0.01. I run to 2 decimal places. So I don't know where this goes. It probably got moved somewhere. So decide which of the following statement are true. There are a limited number of normal distribution. On any normal distribution curve, you can find data value more than 5 standard deviation above the mean. The total area under normal distribution equals 1. The x-axis is a vertical asymptote for all normal distribution. Now, I know it sounds a little bit crazy with all these things. You can think about it this way. There are limited number of normal distributions. It really depends on what they're asking, but I would say no to this because normal distribution is it can be any type of mean. Your mean could be 25, it could be 20. Your standard deviation could be different, so that can change. The only one that's unique is the standard normal distribution. On any normal distribution curve, you can find data value more than 5. Yeah, I mean, it's possible. You can find any data that can be way above and way below. It's just not likely that will happen, but it's a possibility. The total area underneath equals 1. It has to happen. Probability distribution has to equal 1 because they'll be 100%, right? Anything above or below, not going to happen. The x-axis is a vertical asymptote for all normal distribution. Now, for those who haven't taken college algebra, vertical asymptote is just a fancy word to say a line that goes from the top to the bottom where you cannot touch. That is not true in this case. X-axis is like a horizontal asymptote. So this one a little bit tricky, right? So this is it. And it's not very important. It's just kind of, this is really the key one. Number 5, find the area of the standard normal curve to the left equals z equals 0.48. So find the area to the left. I like to write it this way. I will write P, the probability, right, of z less than 0.48. This is how I usually write it. The probability to the left of 0.48. So it's kind of the normal curve that we have just now. Except we're talking about, hey, what is the area? What's the probability to the left of 0.48? And it turns out this guy is not too bad. Right, let me copy this right here. So I'm gonna bold this guy. Now let's see. So let's say we have, I'm gonna copy this as well. So here's the deal. We have a standard normal distribution, right? Has a mean of 0. Right? So maybe I should say it here. A standard normal distribution. The mean is always equal to 0, and the standard deviation is always equal to 1. So this is something that we can reduce every single normal distribution to be by putting into the formula, into the z-score formula. So mean is now 0, standard deviation is 1, so that means there'll be 1, 2, and 3. And you can think about it this way. For the guy that we just have, right, which is 0.48 negative, right? This is the positive 0.48. It will be around this corner, 0.48. It'll be somewhere on this side, like right here. So let me see if I can insert like a shape here, like a drawing like this. So it'll be somewhere along this way. This is like the line for 0.48. And we want to get the left-hand side of this thing. So let me see if I can fill in the... So excuse me, I'm still trying to learn how to use the fancy stuff in here. We would like to know if we can get like a... Let's see, format. Can I paint using this? I guess not. So basically, we want to know to the left of this thing, right here, what's the area, and that is the probability. So let me see the layout. Yeah, because I don't have the nice column thing I can use. Oh well. Oh, yeah, it doesn't. I want something to be on the left, but I guess it's not going to happen. So basically, something here on the left. We want to know what the area is going to be. Now, the whole thing, of course, is 1, right? We want to know what the percentage will be on the left. Now, it turns out we can use our TI-83 for this thing, and it will be extremely easy. All you got to do is press second, then files, just like when we did the normal distribution, the binomial distribution. This time we'll do normal CDF. Always do CDF. Under no circumstance in this class will we ever do PDF. So it does not matter. So we'll just do normal CDF, all right? And we need to know, here's how you use this formula. You gotta do this this command. It's gonna be the left bound, comma, the right bound, then the mean and the standard deviation. So you're like, what are we talking about? Well, let's go ahead and go in here first. So first I'm gonna clear this. Second, vowels. Normal CDF, right? Now, for those who have a fancy TI-84, you will already see the left, right, mean, and standard deviation display on the screen. So it makes it a little bit easier. But if you're using 83 like me, I got like a knockoff version over here. So what is the left bound to this area? That's a question on the left hand side here, right? So if you look at the left hand side, let me see, maybe I can try to help out like this. So we're looking at this part. All right, we're looking at this part. On the left hand side. I wish I have paint here, but like this. So the left hand side here. So the question would be, what is the far left in relation to this shape, right, on the left, the area that I shaded? Well, that will be from here, right, to negative infinity, right? So in our case, it really should be normal CDF, negative infinity. The problem is this. TI-83 or 84 do not accept the number negative infinity. They don't have that. So you have to trick the calculator. And how do you trick it? You just go like this. Negative 999,999. That's good enough. Because that's negative enough to overcome, because we start at 0, right? So we'll do negative 999,999, comma. So what is the right bound? So you go from the left all the way. Now you don't stop at 0. You stop here, right here, at this point. 0.48. Because that's how far we want to go. Okay? And what's the mean? 0. What's the standard deviation? 1. Let's type that in and see. There'll be 0, comma, 1, close parenthesis. And enter. Oh, wait a minute. Oh, that should be a negative, my bad. I'll put a minus instead of negative. So there you go. The answer to this question is 0.1587, right? So you run to 4 decimal places. How many places do you want? Yep, 4 decimal places. So that's the answer. That means from essentially from oh, actually, you know what? I'm tripping. I'm missing something here. Let me do this again. It's negative 999,999, comma, 0.48. I forgot about this one, comma, 0, comma, 1. Now we're talking. So there's my bad. So that'd be 6844. So that means if you take the probability, the area on the left of 0.48 as the z-score, you should get 68.44% of the data. So if you go into a data set, any distribution, if it's normal, standard, to the left of 0.48, you should get 68.44% of the probability on the left. So now let's look at another one here. So now this should be pretty easy, because this one says, find the area under the standard normal curve to the right. This time's to the right. So let me see. Let me answer. So for number 6, this time is to the right of the z-score. So now we're looking at the curve to the right of z equals to 0.52. Now, it's the same problem. It's the same type of problem. To the right of the z-score is always, it's still just normal CDF. You don't even need this here. You can just say normal CDF, left, right, mean, standard deviation. So I drew the picture here. So this is basically what you should come up with, because to the right of 0.52, right, that'll be right here. To the right would be 0.52. That's the left bound of this shape. 999,999, that's to imitate infinity. The mean is 0. The standard deviation is 1. So let's check it out. Second of all, normal CDF, 0.52, comma, 999,999, comma, 0, comma, 1. And that should do it. So I have 0.3015. Pretty easy, right? Just one note, just on the side. You can get away with not putting 0 and 1, because by default, right, if you go do the CDF again, by default, if you do not put any number in those slots, they just assume you have a standard deviation. They just assume you have a standard normal distribution. So they just assume your mean is 0 and your standard deviation is 1, just like that. So, it's very nice. It's just that later on when we do the next chapters and all that, the next session, you're always going to have a different average. So now, looking at number 7, it's the same thing, except they give you a curve like this. So let me just copy that. Let's see. So this time, we got 2 things going. we have here, and it's going to be so right here on the left is negative 1.15. Oh, let me make it a little bit bigger, like that. On the right, it's going to be 2.84. So now look at this. Do you have a left bound and a right bound? I want to know what's in between. So insert, let me get the line going. So it'll be like this. So you got to start from here, and you're going to end right here. And you want the guys in the middle, basically. You want these guys. It's a lot easier to do with a pen. But basically, this is it. Just like that. Like that. So this one's actually easier if you think about it, because this would become normal CDF. What's the left bound? Well, negative 1.15. What's the right? 2.84. And then what's the mean? And well, it would be 0.1, right? So like that, right? And that's it. So second file, normal CDF, negative 1.15, comma, 2.84, comma, 0, comma, 1. And again, we could get away without a 0 and 1, right? So then that's the answer. Equals 0.8727. Again, you know, it's very easy, right? When you know the command and all that. This one is the same thing. The Z, this is basically, this guy right, you can actually present this as a probability of negative 1.15 less than Z less than 2.84, like this. So basically this guy right here is the same thing. It will be normal CDF, 0, 1.91. Same thing over here. Find the area under the standard normal curve to the right of this thing. So this would be probability of Z. So you want to the right, right? So to the right would be Z greater than 2.33. Right. So basically it will be normal CDF. And of course it will be the left. So if it goes to the right, you start at 2.33, going to infinity, right? And then 0, 1. Right? So just try it out on the calculator, you'll get it. Which of the following statement is true? The mean of a normal distribution is always 0. That is not true. The mean of a standard normal distribution is always 0. But that didn't say standard. The line of symmetry for a standard normal distribution is x equals mean. This is actually true. The line of symmetry is the mean in the middle, basically. The inflection points for any normal distribution are one standard deviation on either side of the mean. This one is not true because inflection point implies where it turns. But if you recall the normal distribution thing we had, the inflection point is right here in the middle. The inflection point happens at the average point. So it should be at the mean. So that's not true. The x-axis is a horizontal asymptote for all normal distribution. That is actually true. So as I mentioned before, it's not a vertical, but it's a horizontal. It will never go underneath it. And that is all for these two, basically the basic of normal distribution and standard normal. Pretty simple stuff if you have a calculator. You just got to understand the concept of the graph and what does it actually represent. Because we'll be using the normal distribution to do other things in the later on session.